The last section in Chapter 7 is hypothesis testing for the variance in standard deviation using the chi-square test. Remember, chi-square is this Greek letter capital X. When we're doing a chi-square distribution, you have to use degrees of freedom and finding the critical values from a table in your appendix. That's not something that your calculators can do. We're still going to do left tail test, right tail test, and two tail test. However, remember that our distribution graphs are always going to be skewed right, so they're not symmetric. So if we're going to find the critical value of chi-square for a right-tailed test, it's going to be skewed right, and it's going to be alpha is in this region, and alpha is 0.1. Our number of items in our sample is 26, therefore our degrees of freedom is always going to be n minus 1, which is 25. So using an alpha level of 0.1 and degrees of freedom of 25, we need to look on the table to find where 90% is to the left, which gives us a chi-square value of 34.382. That means this value right here is 34.382, and any number that is in this region, this is the rejection region. If we're going to do a left-tailed test, our alpha is going to be over here, and here our alpha is equal to 0.01, and our n is 11, so therefore our degrees of freedom is 10. So using 10 and an alpha of 0.01, we can get our chi-square value of 2.558. Again, that's from the table. That means any number that is less than 2.558 will allow a rejection of a null hypothesis. And then we have two-tailed tests for chi-square, which means that we have both a left and a right region. This will be half of alpha, which is going to be 0.025, and this will be half of alpha, which is going to be equal to 0.025. Or we can think of this as 1 minus 0.025, which is 0.975. Our n is 9, therefore our degrees of freedom is 8. Using the degrees of freedom of 8 and 0.025 and 0.975, we can get our chi-square left value and our chi-square right value. Our left value is 2.180 and our right value is 17.535. That means any number smaller than 2.180 or larger than 17.535 would amount in a rejection of the null hypothesis. When you are doing a chi-square test, this is a reminder of the steps in order to do it. Remember, here's how we calculate the actual chi-square value when it's the variance. When it's the standard deviation, you just take the square root of that. So let's do an example. A dairy processing company claims that the variance of the amount of fat in whole milk processed by the company is no more than 0.25. You suspect that this is wrong and find that a random sample of 41 milk containers has a variance of 0.27. Using an alpha of 0.05, is there enough evidence to reject the company's claim? So our null hypothesis and alternate hypothesis would look like this. So they're saying that theirs is no more than 0.25. That means that the standard deviation or the variance is greater than 0.25. Their claim is that the variance is less than or equal to 0.25. You want to be able to reject their claim and embrace the second one. That means that this is a right-tailed test. Alpha is 0.05 here. From our table, we can get our chi-square value using degrees of freedom equal to 40. We can get our value of 55.758. Now let's calculate our actual chi-square value by taking our n minus 1, multiply it by our variance of 0.27 divided by 0.25, which gives us 43.2. Now 43.2 ends up somewhere right here, which is not in the rejection region. It is not in the shaded region. Therefore, we will not be able to reject the null hypothesis. We fail to reject there is not enough evidence to show that the amount of fat in the whole milk processed is no more than 0.25.